We've Been Around the Block is a podcast coming to you from the heart of the KZN Midlands. Hello and welcome. I'm your host, Antony Jarvie, and today's very special guest is Lisa Rothmann. Welcome, Lisa.
Thanks for having me, Anthony.
Dr. Lisa Rothmann is a lecturer at the University of the Free State, and she's in the pathology department specialising in Sclerotinia. Lisa, you did your PhD on Sclerotinia?
That is correct, yes. I was under the supervision of Professor Neil McLaren, who had many years of experience with Sclerotinia, sclerotiorum, so it was really a great experience to be mentored by him.
Right. Well, our listeners have certainly shown that there's a need to delve into the intricacies of Sclerotinia in soybeans, and so for that reason we have the expert on the show today. So today's discussion is about Sclerotinia in soybeans, and after this short break we will have a look at the impact of Sclerotinia on our national crop and the different crops affected, the pathogen and all the ways of limiting yield losses to Sclerotinia. So don't go away. Today's episode is sponsored by Panel Seed. So this episode is primarily a soybean-centric discussion. Perhaps it would be fitting to discuss the value of early adoption of new soybean cultivars. Panel releases new soybean cultivars almost every year, and these cultivars are tested for at least 5 years before they reach commercial sales. This extended period is needed to make sure that the varieties have the capability to tolerate almost any seasonal variation that they would be exposed to in the future. This means that the new cultivars that have followed this process may be adopted with confidence in their recommended zones, and that the sooner these varieties are adopted, the sooner you can take advantage of their increased yields. Not all companies have this vigorous testing, but with Panel, you can be assured that they've had comprehensive testing before cultivar release. Right, so we're going to tell you all you ever wanted to know about Sclerotinia. Lisa, just to begin with, what are the major crops that are affected by Sclerotinia?
So I think maybe we can start with the fact that there are over 400 host plants, including crops as well as ornamentals and weeds. But the most affected are usually those of the oil, seed and protein, so canola, soybean, sunflower, especially those that are reported in South Africa. But it has actually made an impact on lettuce, peppers, squashes. It has a wide host range, which I think probably contributes to the need for more information on this pathogen.
Right, yeah. So one of the other crops that I'm interested in is dry beans, and it certainly is a big problem on dry beans too.
That is for sure. And our South African Sclerotinia Research Network has a culture collection that actually includes isolates collected from dry beans.
Okay, right. So just looking at the pathogen itself, do they actually have any sort of specialization? Is the Sclerotinia isolate that you get off, say, dry beans the same or similar to that of soybeans?
Yes, it's actually exactly the same pathogen. Sclerotinia sclerotiorum has the ability to infect butternut, cabbage, canola, dry bean, and soybean, as well as sunflower. So they're all the same, but not. Quite like how we have all our fingers are fingers, but not all fingers are thumbs.
Yeah. So tell me a little bit about the life cycle of Sclerotinia.
Right. So I think the most important part is the sclerotia, because this is the survival structure, which is a melanized mass of mycelium, which is the fungus's ability to actually spread once it has infected the host plant. So what would happen is your sclerotia, or not yours, the
crop sclerotia,
the pathogen,
yes.
The crop sclerotia would germinate either in two pathways, making mycelium, which is that white fluffy material, or by making a small mushroom-like structure known as an apothecia. Now, most commonly, what we've seen in the field doing our research over the last 6 to 7 years has been that of the apothecia structure. And this structure releases ascospores, which is kind of like the bullets of this pathogen. And they can then infect the most sensitive areas of the crop, which are usually the flowering tissues or the senescing flowering tissues. And this obviously differs for the different crops, as you can imagine. A sunflower looks much different to a soybean, but there are a lot more similarities between dry beans, green beans, and soybeans.
Right, yeah. And so primarily that would be sort of at or just after flowering, right?
That is correct, yes. And what we've also noted that's important about the life cycle is once this infection process has started after the dispersal of the ascospores, we see that the infection then spreads to the soft watery rot. Mm-hmm. And as the disease advances, the fluffy mycelium starts to develop. And that's what hardens at the end of the life cycle or when the disease conditions are no longer favorable and melanizes, forming the sclerotia. When the produce is harvested, this is what then either remains within the grain or the seed or back in the soil. And so then the life cycle continues.
Right. One of the things about these sclerotia is that they are hardy, and so they are able to resist quite unfavorable conditions, right?
That is correct. A lot of literature has actually stated that some sclerotia, depending on the size and the host crop, can actually survive for over 10 years. So just the thought of just having that extent of survival is why I think it's important to target the sclerotia when managing Sclerotinia diseases.
Right. So most often they would, well, certainly with soybeans, they would be lodged within the pithy region in the stem and be lying around in the stover, which is left over after the crop.
That's quite correct.
Do they actually have to be buried, or, how do they survive the best, So do they survive better when they've been incorporated, or do they survive better where they left in the stover on the surface of the field?
Yeah, this is a very good question. One of our research students, Mrs. Mathies Meyring, is actually looking at the survival of sclerotia at different heat temperatures and those that have just been left on the soil. And what we've seen is those that are buried at about 5 centimeters have had less germination. But what we think is actually happening is that the stipe, which is the little stem of this mushroom-like structure, doesn't actually have enough to reach out of the soil. But most sclerotia are not buried deeper than 5 centimeters.
Yeah, but so perhaps the thing would be to bury it 5 centimeters and then bring it to the surface, because very often with tillage, that's what happens. You might have something which was buried for 2 seasons pop up and lie on the surface of the soil or very close to the surface, and then probably would be in the range for germination, right?
That is right. Yeah, so I would just be cautious with tillage. I think there's a lot of contradictory research about, to what depth is the most appropriate. After how many years are you going to be, revealing those sclerotia to the surface?
Right. So the other thing that is becoming more and more prevalent is no-till, which actually leaves the soybean stems on the soil surface. But normally with no-till you would rotate. And so is there any sort of stimulus from the crop side to get these sclerotia to germinate?
Well, what we are thinking is happening is, let's say we do a soybean maize rotation. And we've noted that we have some trials in Clocolan in the Free State where there were sunflower previously planted and then maize, and the apothecia have germinated in the field. The producer does practice till practices, but what I'm assuming would happen in a no-till environment is that something similar would happen. Those sclerotia would germinate, which is actually reducing their power to then germinate in the future.
Yeah.
That is not to say that they won't germinate at all.
Yeah, so they're all dressed up and no place to go.
Pretty much. Although, ascospores are airborne. So if you have soybean in the surrounding area, you still stand a risk of Sclerotinia could still develop.
Oh, right, yeah, in neighboring fields.
Yes.
So to what extent is there pathogen diversity which limits our ability to develop resistance to Sclerotinia? Because for as long as I've been a plant breeder, Sclerotinia resistance has been something that plant breeders have been looking at, and to a large extent it hasn't really happened. I do know of some minor elements of resistance or tolerance, but there's been no massive breakthrough in terms of cultivar resistance.
Quite correct. There's only partial resistance available for soybean stem rot, and I think the issue is not so much the diversity of the pathogen, although that is not my forte. Dr. Adri Minard Ontong is a breeder, right. And they actually have over 1,000 isolates in the culture collection, and they're looking at the population and all the different hosts and the different provinces. And it seems that there are some isolates that are more similar to one another than others. So there is some changes and mutations occurring within the pathogen population in South Africa.
Right. Maybe to backtrack just slightly, the Sclerotinia is very widespread across South African summer cropping region. So I know you've done work on sunflower as well, but what is the extent of the impact of Sclerotinia on the soybean crop?
So the Crop Estimates Committee did a survey on Sclerotinia, sclerotiorum, or Sclerotinia diseases, and I was fortunate enough to have access to this data for my PhD research. And they collected data from 2006 to 2015, and each province has a different prevalence. So this is the amount of positive fields that experienced or were exposed to Sclerotinia. And the average across this 10-year survey ranges from 7%, which is the lowest, to a shocking high of 55%.
Wow.
So, and that's for soybean specifically.
Right. Yeah.
And the province that during the survey, the province that had the overall greatest prevalence was in Mpumalanga. But one can also then make some deductions, and KwaZulu-Natal, that, there's a higher amount of soybeans being planted. So the risk is also much higher that there would be more disease.
Would that be because of a combination with sunflower, or do you think that's just because there's a higher amount of soybeans planted in Mpumalanga and perhaps our rotation schedules are not long enough?
Yes, that could be. I also think the fact that they are just, Mpumalanga might also have, and this is just an opinion, that it might also be more favorable, the environment.
Yeah.
That being said, most of the producers that responded to the 10-year survey were either from the Free State. There were over 180 producers that responded from the Free State, and Mpumalanga had 244 respondents. Right. So it's also a truer reflection of, what's actually going on. Right.
Well, so just looking at planting date, because I think what we will eventually come down to is looking at what can farmers do to perhaps limit the losses to Sclerotinia. As the guys up on the high veld with the reasonably short cropping seasons have very little maneuverability in terms of their planting dates. So they only have a small planting window relative to, say, the moderate regions, and so they would be forced to plant within their planting window, which might then be very favorable for Sclerotinia.
Yes, that's very true. And what we also have noticed about planting dates is the fact that, the selection of cultivar, whether they're determinate or indeterminate growth, and the combination of the two can also then contribute to, maybe an increased prevalence.
Right. Just your comment on determinate or indeterminate, what is your view on that for Sclerotinia?
I think it actually, at the end of the day, comes down to, the ability of the cultivar to withstand different levels of disease pressure.
Yeah.
And Madeleine Meyron's PhD also includes then looking at how these cultivars respond. And what we've seen is across the soybean cultivars for the 2019-2020 season, which is unfortunately, not as whole or as complete as we would have liked due to COVID, but we had a mean prevalence across both types at 30%. And there were diverse responses or contrasting responses. So there might have been 2 indeterminate grows and 2 determinate grows that responded, one with a low and the other then with a higher prevalence.
Okay, because then perhaps it's not growth habit, but maybe the length of flowering period, which could be short or long depending on other things, not determinate or indeterminate growth habit.
Yeah, that is very true.
Right. And so cultivar maturity is probably the biggest thing, and perhaps the length of flowering period, right?
Yes, correct. Especially because, the longer the flowering period, the greater the exposure to potential ascospores, which are being released from the apothecia.
Right. I know what they've done in Argentina, where they used to have quite a massive problem with Sclerotinia, is that they moved to shorter maturing varieties in order to try and avoid the period in the season when the environmental conditions would be most favorable for infection. What we haven't quite discussed yet is, what are the environmental conditions that favor infection?
So I think two important factors need to be taken into consideration. The first is that the apothecia need to have germinated. And this usually occurs with a relatively high humidity, but like greater than 85% sun, just enough light through the canopy, and then between 16 to 22 degrees Celsius. So this is what literature has stated. And then we have, the temperatures that are required for infection.
Yeah.
So, that's what also makes this little, this pathogen a trickster, because it has so many different, environmental requirements that it can either wait for the environment to be more conducive for disease development.
Right.
So the infection window then is usually between 20 to 25 degrees Celsius, and this is usually what's initiating the infection on dry beans.
Okay.
But, they've actually noticed very low temperatures, and by very low, from 7 degrees Celsius.
Okay, yeah, but perhaps what it is saying is that there's actually quite a large range. Although the optimum might be between 20 and 25, it can still infect at reasonably cool temperatures too.
Yes, and I think what's important to keep in mind is, that the moisture can also then contribute to a cooler temperature or a more, humid environment, which is also going to advance this disease development.
Right. And so, if you think about those conditions, the first thing any producer would think is, what are the plant population conditions that would favor the development of Sclerotinia? And it's likely high plant populations?
Yes, there has been a lot of literature that reports that higher populations means that those canopies are closing much, I'm going to say more rapidly, but the density is much higher. So what's happening is that moisture is being reserved. And when we go do our field trials, even though it hasn't rained for 3 days and we go for a walk early morning, our booth gets full of dew.
Yeah.
So it just shows that, there's a lot of moisture that collects in the canopy.
Right. And is there any effect of light? Because, so plant breeding, we've looked at developing varieties with lanceolate leaves, so those narrow leaves, which allow better light penetration into the canopy. Do you think this could influence the conditions for or against Sclerotinia?
Potentially. However, the light component is actually most critical for the stike, the little neck of the mushroom-like structure. So it actually grows towards light. So you might actually be promoting, the potential is you might promote that apothecia's development towards light, which means, ascospores may be able to release more readily into the air. But this doesn't mean that, just because your apothecia are blocked by the canopy, they're not necessarily getting out.
Right. And row width, so obviously with wider rows, you have more light entering into the canopy and perhaps a less humid environment. And so as your plant population increases and your row width narrows, you have an increase in your humidity and a decrease in your light penetration into the canopy. So how does that affect the Sclerotinia's ability to infect?
So interesting enough, if I think of our trials that we've had in Dalmas, our soybeans, every year we've been planting them at the 76 centimeters. And when I go and compare it now with the sunflower, you don't have bushy canopies. But if I just think of our sunflower fields, we have apothecia that are developing next door where the maize is growing. And they are still germinating, even though there's a lot of, open air, open canopy. So I think maybe row width is something that could be valuable, but you as a producer then need to consider, the potential losses that you might suffer if you don't have Sclerotinia and you have a reduced population.
Right. So there's probably two different things. The factors that influence the sporulation and the factors that influence infection. And they might actually work not against each other, but actually in combination. And so the final effect is you really need to figure out which combination of planting conditions is perhaps best under your conditions, right?
Yes, I think we need to also keep in mind that my advice to many producers at Farmers Days is, if you have had Sclerotinia in the past, go and mark out on a map or go stand in the field and make a GPS, on Google Maps. This point I had Sclerotinia in the past. This is also then how you can know, like in the future, go and inspect for apothecia, even before the canopy starts to close, because that'll give you an indication what kind of risk you have.
Yeah. Are there any traps out there that people can deploy to catch spores?
So currently, none that I know of that are, affordable. Otherwise, we would have one on our research group.
Yeah.
But what I've seen done and what we're trying is there's artificial media that you can use in the field. And if ascospores land on this media, it changes color, and then you know that it is Sclerotinia sclerotiorum spores. However, some common contaminants can also then cause this change in color. So these are things that we're trying to optimize to be able to know, if there are spores present. But it is best to, get out into the field, go into your canopy or go into your dry bean or soybean field and have a look if you can see any apothecia.
Yeah, the problem is that many producers would struggle to perhaps identify fungi at that level, so it does take some sort of specialization. Most farmers understand plants and perhaps less affair with fungi.
Yes, so what we've seen is many producers at Farmers' Days actually ask us, they have photos and they show, is this the apothecia? And many producers confuse the
bird's nest
apothecia with the bird's nest fungus.
Yes.
So I have a link that you can share to your audience through the network that kind of distinguishes, what to avoid or like how not to get confused with the two. The lovely clear photograph can assist producers.
Wonderful. I'll put that link in the show notes.
Also, they're, of course, welcome to send any photos through to the network as well, and we will help them.
Okay, great. Also, at the end of the show, we'll give the IP address for the Sclerotinia Research Network, right?
Yes, that's correct.
Okay, good. Biological control, is there anything on the cards at the moment?
Depends on how we consider to define biological control. We either have those products that are, focusing on the secondary metabolites, so potentially triggering the internal defense mechanism of a crop, or something that is physically mycoparasitizing the sclerotia. Okay. So there are two different avenues, I'd like to say.
Right. So the first is a bit like vaccination for COVID, right?
Yes.
Yeah.
So I think if I think of a product that targets a sclerotia, it's something like Minithyrum minitans. It's a fungus. And it actually eats the rind, the melanized rind, eats in inverted commas, the melanized rind of the sclerotia, which means it's degrading the ability of sclerotia to survive. And without this, survival mechanism, which means you're going to have lower germination. Right. So that's something that I think is very valuable because you're targeting the problem and not just, the symptom.
Yeah. And also then, the length of period which the sclerotia can potentially affect a field, right? Because, if it's up to 10 years, then it does sort of limit your rotation.
That's very true. And I think something that we can't ignore is the fact that most control agents, whether they be chemical or biological, are expensive. And, something that is kind of looking at reducing the potential for disease through the ability of sclerotia to germinate isn't just going to be solving a problem for one season, but for multiple seasons.
Right.
Although that comes at a cost.
Okay. It's sort of like a long-term solution which probably every farmer should employ, but perhaps on top of that they may need to still do some chemical control and while
potentially
and so while we're discussing chemical control, how effective is it?
So currently in South Africa there are 2 registered products for soybean. Persimmidone is registered for application on dry bean, green bean, soybean and pea, and canola has been controlled with either azoxystrobin or prothioconazole and tebuconazole combinations. And then Benamol is the only registered product for sunflower seed treatment that is also registered for soybeans. That being said, the effectivity of these products is something that our research group is currently looking into, as well as new products that potentially can be used, because we know that these products can be expensive, not only to buy, but to apply. And then, you have this hope that it reaches or penetrates the canopy.
Yeah. And, is it the application stage or is it just the effectiveness of the active ingredient that determines this? Because I have a feeling that, perhaps also like with soybean rust, it's very much when you apply, and so if you catch it at the absolute right moment, it works pretty well and otherwise not so well.
Yeah, I agree. It is about when you apply. And I think that's why knowing your risk for the presence of apothecia and ascospores is so critical. And most of the registered chemicals are then, saying at flowering, because we know that that's a risk period.
Mm-hmm. Right. And so post-flowering, what are the risks post-flower?
I think post-flower, the risk is that, you have a higher chance or a higher likelihood that sclerotinia is going to develop with that senescing tissue. And once the symptoms are there, they may continue to develop, but the extent may not be, as high as you would without applying. But there is no yield research yet to actually confirm whether that's a reality.
Right. And then very lastly, having been in the seed business all my life, certified seed versus uncertified seed, and to what extent sclerotinia is carried in or on the seed, right? So there's a difference. Let's just start sclerotinia and seed-borne capabilities.
Perfect. So I think the first thing to recognize is that there's a difference between, the mycelium being inside the seed and the sclerotia being in the seed bag. So let's start with the seed itself. We know that Sclerotinia sclerotiorum has the ability to survive in diseased seed. We currently have a student that is busy doing a trial on how frequently is this occurring. And it seems that it needs to be relatively diseased seed, although we have seen some that has had, germinating mycelium from healthy looking seed.
Right.
That being said, it's a very small proportion.
Yeah. And do those seeds actually germinate? Because obviously, so from my experience, we're seeing seed visibly infected with sclerotinia, that those seeds are not going to germinate. Sclerotinia is less likely to be transmitted by seed-borne disease. It's more the sclerotia within amongst the seed is really,
Yeah, so it is more likely to be the sclerotia inside the seed bag. And South African legislation has the maximum allowable limit to 4% sclerotia, which I know it sounds very high, but we're one of the few countries that actually has any legislation protecting producers. So I think that's something that we can, as producers, be aware of, and researchers, I suppose, because without that, what do we have without, that 4% protection? And then we have the South African National Seed Organization that have really taken the next step and have a maximum level of 0.2% sclerotia permitted.
Reducing the amount of sclerotia within the seed bag is important.
Yes.
Yeah. Is there anything that you can think of in addition to what we've discussed which would help producers limit their losses?
If, as a producer, you can only control 30%, try and make the most of controlling that 30%. And that means that, we need to prepare our fields to the best of, our ability. And sclerotinia isn't the only problem that producers are being faced with in their systems. So I think the best is to, think of sclerotinia throughout the season, but keep it in mind at the beginning of the season so that you can go and do spot checks for those apothecia, contact the network and ask, is this sclerotinia apothecia? That's why we have the network.
Mm-hmm. Right. And before we wrap up, do you want to give us a contact address for the network?
Yeah, sure. So if you are interested in looking up the website, you can go and look at sclerotinia.co.za, or you can contact the network. We call it the hotline. The cell phone number is 079-270-9691. And you can reach out via WhatsApp or give us a ring, and we will freely advise and give an opinion, on options you have for management available. We also do Farmers Days. There's a Facebook page for the South African Sclerotinia Research Network, and we try to put up some helpful tips, on identifying symptoms and different control mechanisms and what research is being done within the network.
All right. Well, Lisa, it's been wonderful chatting to you, and until next time, it's been a gas. Take care.
Thank you. Have a lovely day.